2.5, we left off, we were talking about normal distributions, so the mean, standard deviation, and so on, the bell curve, right? So we left off on number 3. So it says a normally distributed data set has a mean of 25 and a standard deviation of 5. So we put the mean in the middle, the standard deviation is 5. Oh, whoops, I won't do that there. What a standard deviation means is it's kind of like the spread of the data. So it's telling you how far out you go to have 68% of your population and so on. So like one standard deviation away in both directions, like if I go from the mean and I go one standard deviation out, that's 68% of your data is within there. If you go 2 standard deviations out, then that's like 95% of your data. Okay, so there's different ways of determining how much data you have in there. So anyway, so we're at a mean of 25. Our standard deviation is 5. Find the probability that a data value chosen at random is greater than 28. So we're going to say x equals 28. And we're shading on the right side of it. So we're saying greater than 28. Oops, I wrote 25, 28. Okay, so we can't look up an x value on our little table. We have to look up what's called a z-score. So we change it. So we do z equals x minus mu over the standard deviation. So I have 28 minus 25 all over standard deviation of 5. So I have 3 over 5, which is 0.6 or 0.60. So then I flip to my chart. So everybody do this along with me. Flip to your chart. Some of the most basic errors are from looking up the chart, looking at it wrong. So I'm going to go down to 0.6, and I want 0.60, so I have this number right here. So 0.7257. So that's representing about 72% of your curve. So 0.7257. So we decide, is that from here over, or is it from here over? 72% of your curve?
Oh, no.
Yep, so 0.7257 is that way. All right, so we don't want that part. We want the part on the right? We want the shaded portion. So what we do is we do the rest of it. We take 100% minus 72%, and we get around 28%, right? So we're going to do 1 minus 0.7257. And I taught you how to do this in your head last time. Every number adds up to be 9, except the last number, which adds to be 10. So I need 7 and 2 make 9, 2 and 7 make 9, 5 and 4. And then I want the last number to make 10, so I need a 3. So 0.2743.
So there's a 27%.
Yep. All right, next one. So a normally distributed data set has a mean of 40 and a standard deviation of 8. Find the probability that a data value chosen at random is greater than 35. So we're shading on the right because we said greater than 35. Okay, so I want to change this to a z-score. So I do z equals x minus mu over the standard deviation. So I'm going to have 35 minus 40 all over, standard deviation is 8. So I get negative 5 over 8, which is negative 0.625, right? Okay, but I can't look up 0.625 on my table. What do I need to look up? Yeah, I need 2 decimals, so negative 0.63 is what I'm going to look up. Okay, so I'm going to go to my chart and I'm going to look up 0.63 because I can't look up a negative. So when I go down to 0.6, I'm going to go over to 0.03. So I get that number right there, which is 0.7357. So I say, what represents 0.7357? Well, that would be from here over, 0.7357. It has to be more than 50% of the curve, right? More than just 1/2 that bell curve. Okay, and that's exactly what I want. So my answer is 0.7357. Right, I didn't have to do the 1 minus because I didn't want the other portion, the smaller portion. I wanted the big portion. Okay, making sense? All right, so you might have some story problems like this. Like I think on your homework you talk about a fire truck coming within a certain amount of time, and I don't know, there's lots of things you can do with the bell curve. So this one talks about a radar unit is used to measure the speeds of cars on a road. The speeds are normally distributed with a mean of 90 kilometers per hour and a standard deviation of 10. What is the probability that a car at random is traveling more than 95 kilometers per hour? Okay, so we're going to shade on the right side. So I need to change it. So I do z equals x minus mu over the standard deviation. So I have 95 minus 90 all over 10. So I get 0.5. So when I look up 0.5 on the table, I have it memorized because I do it so many times, 0.6915. So you can look it up, 0.6195 or 6915. That represents more than 50%, right? So it's this one on the left, 0.6915. Do you see how important the sketch is? You really need the sketch to decide which side you're talking about. A lot of people in first period were just trying to like do these problems without the sketch. And they kept saying, wait, when do you subtract from 1? When do you find the tails? When do you just subtract the 2 numbers? Right? And I was like, did you draw a sketch? And they said, no. And then they asked me like 5 minutes later, well, why did you? I'm like, did you draw a sketch? No. So I said I wasn't going to answer any more questions, so I drew the sketch. It's very important. All right, so anyway, so I don't want the big portion of this curve. I want the small portion. That's the part that's shaded, right? So what I do is I do 1 minus 0.6915. So I get 0.3085. That's your answer. All right, number 6. So entry to a certain university is determined by a national test. The scores on this test are normally distributed with a mean of 500 and a standard deviation of 100. I talked about Dimitri, but then I talk about Tyler. So we'll say Tyler wants to be admitted to this university, and he knows that he must score better than at least 70% of the students who took the test. Tyler takes the test, and he sees that he scores 595. Okay, will he be admitted to the university? So we want to know what percent of people scored less than him. So what's the probability that someone was less than what he had? So I do that. So I do z equals x minus mu over the standard deviation. So I have 595 minus 500 all over the standard deviation is 100. So I get 95 over 100 is 0.95. Okay, so I look up 0.95 on my table. So you can go back to the table. If you look up 0.95, you go down to 0.9 over 1, 2, 3, 4, 5. Right there. So 0.8289. Okay, so that's going to be the percent of people that score less than him. So 0.8289. Is that what I said? 0.8289. Mm-hmm. All right, so that means that he scored in the 82nd percentile. So he scored better than at least 70% of people, right? So yes, he would be admitted. All right, so let's say that Tyler wants to do the bare minimum. He wants to know exactly what he's going to get on this score to just get 70th percentile, like you would do that when you're going to college, right? I'm just going to get the bare minimum. I don't care. I'm not going to have anyone check my essay. I don't care. I'm not going to study. All right, so same thing. So he wants to get in the 70th percentile. So this is a different type of question. Okay, I haven't asked you one of these questions yet. It's different. So if he wants to score in the 70th percentile, that means that 70% of students scored worse than he did. Okay, so inside this little area here, I need 0.7000. That's a probability. So basically what we're talking about is when I look at the chart, I need to look in this area and find 0.7000. That's what I'm looking for. Do you understand what I'm saying? I'm finding the probability. So I want to know the z-score that goes with it. Oops. Get rid of that. So that's what I'm missing. I don't know the z-score. I want to find it. So find the z-score that gives 0.7000 as a probability. Okay, so I'm going to go to my chart and I'm going to look for 0.7000. Do you guys see it? It doesn't come out perfectly, does it? All right, so if I look up 0.7000, I'm between here and here. So I'm between 0.52 and 0.53. 0.52 gives me 0.6985. And 0.53 These are both z-scores. 0.53 gives me 0.7019. So the question is, which one is closer? Kind of a trick question. You could pick in between it. You could do 0.525, and when I make the answer key, I actually do that as well. But I would just pick whichever one's close. Okay, which one's closer? So I heard someone say 0.7019. It is not the one that's closer. Yeah, this one is 0.0015 away. And this one is 0.0019 away. So it's actually 0.52. Okay, so I'm going to use 0.52 as my z-score. So I'm going to use 0.52 as z. And what I need, I mean, that's really nothing in this problem, right? I can't, you're not saying, oh, he needs to score a 0.52 for his score. That doesn't make any sense. That's a z-score. It means like nothing right now. What do I need to change it to? I need to change it to not the percent. I already have the percent, 70. I need to change it to like the number, right? The x value. Okay, so I do that with my same equation. Z equals x minus mu over the standard deviation. But this time I have the z. So I have 0.52 equals x minus, my mean was 500, my standard deviation was 100. So I'm going to take my 0.52 times 100. I don't know why I just took my calculator like I had to multiply that with my calculator. I can do that. 0.52 times 100 is 52. Add my 500 over, so I get 552. That's the score that he needs to get. Does that make sense? So it's working backwards. You're finding the z-score that goes with a certain probability. Okay, so you might have something like that in your homework too. All right, so let's try a couple more. Okay, so number 7, it says for a certain type of calculator, the length of time between battery replacement is normally distributed with a mean of 50 hours and a standard deviation of 15. Mr. Cyric owns one of these calculators and wants to know the probability that the length will be between 60 and 70 hours. What a nerd. All right, so let's figure it out. So I need to change both of these to z-scores. So the first one, I'm going to do x minus mu over the standard deviation. So I have 60 minus 50 over 15. So I have 10 over 15, which is 2/3, which makes 0.67 if I find it. All right, the other one is going to be 70 minus 50 over 15. That's 20 over 15, which is 4/3. So that's going to be 1.33 if I find that as a decimal. A two decimal place, I guess. All right, so I need to look both of those up in my chart. So when I look up 0.67, so going back to my chart, I have to go way back. Okay, 0.67. I go to my 0.6 column or row, I go over to 0.67, it's right there, 0.7486. Okay, so that's here over. So 0.7486. Okay, but if I look up 1.33, 1.33 gives me 0.9082. So this other one gives me 0.9082. So how do I find it? Yeah.
Okay, so first you have to do 1 minus 0.9082.
Okay, to find the tail? Okay. You could find the tails. You don't have to on this one. What else could you do? Yeah, Abby?
Don't you do 0.9082 minus 0.7?
Yep. 0.9082 minus 0.7486. Exactly. So you can do that. So this one you don't really need the tails. It wasn't like both your z-scores were on opposite sides of the. That's when I would recommend finding the tails if they were on like one was positive, one was negative. But if they're on the same side, you can actually just take one minus the other. Does that kind of make sense when you see the picture? Okay, so if you subtract it out, let's see, 6, let's see, 7, 1, 9, 5, 0.1596. Did you guys get that? Okay. All right, number 8, the annual salaries of employees in a large company are approximately normally distributed with a mean of 50,000. a standard deviation of 20,000. That's my sigma. What percent of people earn less than 40,000? Okay, so I change it to a z-score. So I have z equals x minus mu. Lots of zeros. All over the standard deviation. You could chop off those zeros, but you'd have to be consistent on all of them. All right, so I get negative 10,000 over 20,000, so I get negative 0.5. So when I look up 0.5 on my table, I get 0.6915. So here's my dividing line. Do I go on the right of the dividing line for 0.6915 or the left of the dividing line? The right, right? This is 0.6915. More than half of the probability is in that white area. Right? So I want the shaded area. So I want the rest of it. So I do 1 minus 0.6915. We've had this number a couple times, haven't we? So 0.3085. That's your answer. All right, so this one's saying, well, what percent of people earn between 45,000 and 65,000? Okay, so this is going to be one where you need the tails. So we haven't done one like this today. We did it in the last lecture. But we're going to need to find these little tails here. Okay, so let's first change these to z-scores. So I get z equals 45,000 minus 5,000, or 50,000, divided by 20,000. So I get negative 5,000 over 20,000, so negative 0.25 for the first z-score. And then the other z-score is going to be 65,000. Geez, I'm seriously struggling with my zeros here, aren't I? All right, minus 50,000 all over 20,000. So I get, let's see, 15,000 over 20,000, so 0.75. So I'm going to look up both. So when I look up 0.25, because I can't look up a negative, 0.25, I get 0.5987. Okay, that's going to be the part that goes to the right, 0.5987. All right, more than half. When I look up 0.75, I get 0.7734. Run out of room. 0.7734. I don't know if you guys can see that. Maybe I'll erase it. So you can write it in there. 0.7734 goes that way. Okay, so I was saying these ones, this would be where I would find the tails, right? When you have a negative z-score and a positive z-score, I would just go ahead and find this tail and this tail. Okay, so if I find the left tail, I'm doing 1 minus 0.5987. So you can write this down or you can do it in your head. 1 minus 0.5987 is going to be 0.4013, right? Add 9, 9, 9, 10, right? So I get 0.4013 on the left-hand side. And then the other one is 1 minus 0.7734. So that's going to be 0.2266. So those are the tails. So how do I find my final answer?
Subtract the tails from 0.5987.
Yeah, you could do either one. So you could do 0.5987 minus the 0.2266. That gets it for you. Or you could do 0.7734 minus the 0.4013. It gets it for you. I usually do 1 minus both of the tails. But it's the same thing. You can do it the other way too. So 1 minus 0.2266 minus 0.4013. So 0.3721 is your answer. All right, is this making sense? All right, so let's skip C. Let's go down to 9. We'll do 9B and C. So it says the time taken to assemble a car in a certain plant is normally distributed with a mean of 20 hours and a standard deviation of 2 hours. What is the probability that a car can be assembled at this plant in a period of time between 21 and 23 hours? So we have our mean is 20, and we want to find between 21 and 23. All right, so I'm going to change them to z-scores. So I get z equals x minus mu over the standard deviation was 2. So I have 1 over 2, which is 0.5. And the other one I have 23 minus 20 over 2, which is 3 over 2, or 1.5. So when I look up 0.5, we've looked that up several times today, we get 0.6915. So that is going to be the area, or the probability on the left, 0.6915. Okay, see how it's more than 50%, more than the center line of the bell curve. All right, and then the 2023, that gave me a z-score of 1.5. So when I look up 1.5, I get 0.9332. So what would you do? Yeah, 0.9332 minus the 0.6915. So what do we get here? A number, thank you. 0.2417. All right, and the last one I want you to do, because it's one of those ones where it gives you the probability. So it says, how many hours will it take to guarantee that the car is finished 95% of the time? So a certain time period of the day, or a certain time period, is going to give me a 95% chance that it's going to be done. So inside here, I'm going to have 0.9500. That's my probability. So we want to know what z-score gives a probability of 0.9500. Okay, so that means in my chart, I am looking up in the middle of the chart. Oopsie, sorry, really confuse you. All right, in the middle of this chart, I'm going to look up for 0.9500. So I'm looking in here. I'm trying to find 0.9500. Do you guys see what ones are close to it? So a z-score of 1.64 gives you 0.9495. A z-score of 1.65 gives you a probability of 0.9505. Which one's closer? They're the same distance. They're all 0.0005 away. So what would you choose? It doesn't matter. You can choose anyone. You can choose 1.64, you can choose 1.65, or you can do what Emily was suggesting, which I would actually do in this case because they're an equal distance away. I would choose exactly in between. I would choose the average of the two. So what's directly between 1.64 and 1.65? 1.645, exactly. So I'm going to choose a z-score of 1.645. And on your test, I'm not like too particular about what you choose. So I would write a key that would involve 1.64, one that would involve 1.65, and one that would use the average of the two. So it's up to you. Is this chart in your calculator? There are ways to find it in your calculator, but it's not like actually a chart in your calculator now. I will give you a little sheet that has the numbers on it. All right, so we have the z-score, so now we need to find the x. So x minus mu over the standard deviation, that gives you your z-score. So I have 1.645 equals x minus mu was 20 over standard deviation was 2. So I'm going to multiply the 2 over. Yep, and then I'm going to add the 20. Good. So 23.29 hours. So if someone was in a hurry to get their car, so this is a plant that assembles cars, and you were like, oh, when will you have this car done for me? I would say, oh, probably around 24 hours, right? At most 24 hours. All right, that's it. Any questions on 6 point, or not 6.5, what am I talking about, 12.5?